There we go. So when you're asked to find the average value of something and they just give you 5 numbers, you just add them all up and divide by how many there are, right? So if I was asking you to give me the average of these 5 numbers here, you would just say, oh, that's easy. That's just the sum of these numbers, right? Divided by how many there are. In this case, is divided by 5. Yeah? And that's the idea to calculate the mean or the average. Now, that's all well and good when you have discrete numbers. Discrete being that it's just one number jumping to the next number. So like 10 plus 11 plus 12 plus 13 plus 14, right? But what if the thing that we're dealing with isn't discrete like this? Because in calculus, we don't really just deal with discrete numbers. We deal with functions that are continuous, right? So we don't just have like, 10 plus 11 plus 12 plus 13 plus 14 divided by 5. What if instead I wanted the average for a function that looks something like this? Let's say instead of that, I have a function here that is this function right here, and we call that f of x, right? So let's say it does have a value of 10 in there. It goes 10, and then it goes to 11, then it goes to 12, then it goes to 13, then it goes to 13.5, then it goes to 14, right? And I wanted you to tell me the average of this from, let's say here, this point right here, let's call that A, all the way to here. Let's call that B. And I wanted you to calculate that average for me. Now, you kind of want to follow the same rules, right? Just add the function values along the way, add them all up, and then divide by how many there are. But there's a problem with that, right? There's infinitely many points there. If I were to add this all up, right? If I said, you know what, I'm just going to say, okay, let's add this point right here. Let's call that f of x sub 1 plus f of x sub 2, right? Plus f of x sub 3. That's this point right here, right? Plus f of x sub 4, so on and so forth. If I were to add all those up, how many can you picture there that's between A and B? And hopefully that you can picture it. There's infinitely many. I drew these a little bit spaced out, but if you were to zoom in, you'll say like, knock me, there's also a point between here and here. And there's also a point between those points. And if I keep zooming in, there's also a point that's between those points. And there's infinitely many points between there. So technically, in theory, I'm supposed to be adding up infinitely many points from x sub A, right? F of x sub 1, which is the beginning point over here, and add up all the infinitely many points to here, right? And that's going to be a little bit troublesome, isn't it? Right? The idea is I'm supposed to take, so this average, right? This average, by the way, I'm using mu. You guys okay with the symbol mu? Right? Mu is, if you're taking statistics, this is the symbol for the mean, right? Or the average. So I'm calculating this mean. What I'm basically doing here is I'm going through here and I'm just adding up all the function values, right? For f of x sub 1 plus f of x sub 2, right? And I'm doing this for infinitely many of these guys. There's f of x sub 3, and it just keeps going. Why? Well, forever, right? Forever. And then, of course, I'm supposed to divide by however many numbers there are that's between them, right? Let's just call this f of x sub n for now, right? And we would just divide by n, right, for however many numbers there are that's supposed to be between this, right? Well, it's a little much. It's a little much, honestly, if we take a look at this. So what I'm going to do is just a little bit of like rewriting just to show this right here for you guys. And if you have a question, let me know. Let me know, because it's going to get a little weird, but it's okay that it's going to get a little weird. Don't. If this is too much, just worry about the end result, and you'll just apply the end result to what we're going to get right here. So let's check this out. I'm summing these guys all up, right? I'm adding these all together. So this is the same thing as the sum, right, of f of x sub I. And x sub I just means it's a placeholder. It's a counter for which part you're at. So if I'm like at x sub 1, x sub 2, x sub 3, x sub 4, right? Of course, they're supposed to be infinitely close to each other because there's infinitely many numbers because it's continuous, right? Divided by however many total numbers there is, right? Now, check this out. I'm doing this as I approaches 1 all the way to however many numbers I'm going to be dealing with on this closed interval here, right? Now, this might look a little bit familiar, right? This summation notation right here, right? Now, check this out. If I do a little bit of like rewriting here, right? I can change this around and write this as, you ready? This n, right, depends on how many n's we have here. I can just rewrite that as delta x divided by b minus a, right? Remember, the number of rectangles we have in there, right, it will be the width of this thing all the way across divided by how far it is from here to here. So I'm going to replace this guy right here and rewrite this as the summation as I goes from 1 to n of f of x sub I times delta x, right, divided by b minus a. I'm replacing this n right here with this. Now again, this is all kind of like funky. You don't have to memorize these steps. I'm just showing you where this formula actually comes from. That's the idea of today's lesson, okay? So here's the thing. Remember, I'm trying to calculate the average value of this function right here, and I'm supposed to just add all these up. Here, 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 here. I'm supposed to add all these numbers up here, but there's infinitely many numbers, right? And right now, all I have is a notation that does it for a set number of values. So if like n was equal to 10, I'm finding 10 particular values here, adding them all up and dividing by 10, okay? To make this so I can do it for infinitely many, I have to take the limit of this. You ready? So what I can do, right, is take the limit as n goes to infinity, right? So there's infinitely many n's here, right? For this summation notation of I equals to 1 to n of f of x sub I delta x. We've already learned this. We figured this out. When I take the limit of the sum of these numbers up here times delta x, this is what we figured out it comes out to be. It comes out to be the integral from a to b of f of x dx, right? Now, all I'm saying is if I'm just looking for the average, why this right here, this part of it can be found by taking the integral from a to b of f of x dx. I can find the sum of all of those infinitely many numbers from a to b just by doing the integral of f of x from a to b. Well, what if I'm looking for the average then, knock me? What if I'm looking for the average of something? Well, that takes me back to here. To find the average, right? To find the average value of f of x, I'm saying this. It's just going to be equal to that integral from a to b of f of x, because that's the sum of all of your numbers, divided by b minus a. That's this part in purple right here. So to calculate the average of something, you can just take the integral of it and then divide it by b minus a. But this looks messy. This looks sloppy. When you find these in your books, they don't define it as this, but that's generally where this divides from b minus a comes from. It's the division of this total right here. But they don't write it like that. To calculate the average value of a function f of x, they write it as the integral from a to b of f of x dx, but they multiply it by the fraction 1 over b minus a. And that is what we use to calculate the average value of a continuous function, which I always thought was like this weird equation, right, that I just kind of memorized. But hopefully this makes a little bit sense as to why this equation works the way it does, right? It's connected to how you used to calculate averages in the past, right? How did you calculate the averages in the past? You added up a crap ton of numbers and divided by however many there are. By the way, crap ton is a calculus term there, right? And when I'm trying to do it for this particularly continuous one, there are a crap ton of numbers. In fact, there's infinitely many numbers there between a and b. And the integral function, right, this thing that we've worked on last week, we found out that it's just a fancy way of adding up infinitely many numbers here that are between a and b, right? So if I need to calculate the average value of a function, all I really need to do is do the integral of that function from whatever to whatever I'm trying to calculate the average value of, and then divide it by b minus a. And that's going to be it. Let me see here. I forget what time this class ends. I should know this, by the way. What time did the class start at? Anybody help me out here? What time does class end today, so I know that I don't take in too much time? Oh, that was turned off. 10:15? Perfect. I got about 15 minutes. Perfect. Let's do an example of this. How to use the average value of a function, or how to find the average value. So let's go ahead and do that real quick. So the example here is going to be finding, right, the average value of f of x equaling to 4 minus x squared on 0 to 3. On 0 to 3. Okay? So this is, this is it right here. How to find the average value. That is horribly written. Average value of this function right here. Okay? So again, we have the formula right here. If I ask you to find the average value of a function, bam, you just plug in this formula right here with whatever you have. So here's my f of x right here. Here's my a and here's my b. Okay? So if I ask you to do this, all you got to do is use this formula. 1 over b minus a times the integral from a to b, right, of f of x dx. So when I plug this in, this is going to come out as 1 over 3 minus 0 times the integral from 0 to 3 of 4 minus x squared dx. Which we've practiced doing this by hand last time, right? This should be equal to 1 over 3 times, and then we do this integral right here that's inside here. The integral, or the antiderivative of 4, if you remember, right, is 4x, right? Because the derivative of 4x is 4, minus the antiderivative of x squared is going to be 1/3 x cubed. 1/3 x cubed. How do I know it's 1/3 x cubed? The derivative of x cubed, we'd bring the 3 down. The 3 and the 1/3 would cancel. And then this would be x squared, right? X squared. Okay? And this, of course, is going to be evaluated from 0 to 3. Okay? So this right here, right? This is the integral stuff that we've been practicing last week. And that's what this is. All I'm telling you right now is to calculate the average value between 2 points from a to b of a function, you just have to add on this extra thing right here, which is what we divide by when we were calculating the average, right? That's where this is coming into play, this 1 over 3. Okay? You would just evaluate this out. This would come out to be, I don't know, what would this come out to be? This would be 1/3 times 4 times 3, which is going to give me 12. Minus 3 cubed is 27 divided by 3 is going to be 9, right? And then when you plug in 0, you just get 0. So I'm not even going to bother plugging in the 0 because the zeros just cancel out to 0. And then when you simplify this out, we end up here. All this work, we end up and find out that the average value is equal to 12 minus 9 is 3. 3 times 1/3, it's equal to 1. And that's the answer right there. The average value is 1. Okay? Now, the idea behind this is if I was looking at this function on a graph, right? 1, 2, 3, 4, and it crosses down here at 2, it looks like. So 1, 2, it looks something like this. Down to here. So looks something like that, right? So this is going to go from 0, and then at 2, it crosses right here, but we're calculating the average value from 0 all the way to 3. And if I plug in 3, 3 will be down here. So this right here will be 3 comma -5. And over here we have 0 comma 4, right? So what I'm saying is if I were to add up all these numbers, right? The numbers right here, if I were to zoom in here and add up all these infinitely many numbers, 4, 3.9, 3.8, 3.7, 3.6, 3, 2.9, 2.5, 2, 1.5, 1, 0.5, 0, -1, -0.1, -1, -2, and -3, -4, -5. I would take those numbers, I added them all up, and then divided by however many numbers I were to do from here to here, and there's infinitely many, I'm telling you that the average value is going to be equal to 1. That's what we found there. So we're this whole idea of taking integrals, I'm just showing you another application of it. You can actually calculate the average value of a function now and when you know how to do integrals. Okay, that's the idea behind there. And being able to calculate that leads us to a random idea here, is that you can actually find a value between there that should be equal to that average value. You should be able to find a function value that's between a to b that is equal to this average value right there. And it kind of makes sense that it does, since this thing is continuous, right? Since this function in particular is continuous. This is right here at a, we have a function value of 4, and at b, we have a function value of -5. Therefore, right, the value of 1 should exist somewhere in between, and there should be a value that is in between there that should spit out the value of 1. So what I'm saying is the function f of x, right, at some point should equal to 1, and we could be able to solve that algebraically. So we would just sit down here and plug in 4 minus x squared. When does that equal to 1? And we would just do a little bit of algebra work here, and we find out that x should equal to either plus or minus the square root of 3. And on the interval that we're looking at here, the interval that we're looking at is from 0 to 3. So the one that we care about is the positive one of that. So what I'm saying is we could say that, oh, at x equals to the square root of 3, right, we have the average value right there, right? So at the square root of 3, that f of x value is equal to the average of itself. A little bit different from the mean value theorem when we first learned it. Remember the first time we learned the mean value theorem? We learned that if we calculate the slope between the endpoints, the derivative value should be somewhere in the middle, or not in the middle, in between those two. I'm just saying that the mean value theorem also applies to integrals, and that's what I'm going to write out for you guys right here. Don't worry if this is too much, like this part right here was like a little bit too weird. Just kind of get this part down over here, this equation right here. The average value of f of x is equal to 1 over b minus a times the integral of a to b of f of x dx. I'm going to give you the theorem right now, just to show you here, for the mean value theorem of integrals. Okay, so let's write that down right here. The mean value theorem of integrals. The mean value theorem of integrals. Okay. So for this one, it always starts off with the same idea. If f of x is continuous on a to b, then at some point C in a to b, f of c should equal to 1 over b minus a times the integral from a to b of f of x dx. So there's a value that's in there that should be equal to the average value of f of x. Right? There should be a value that's in there that's equal to that average. Okay? And then most of the times they'll ask you to find that value, and you just have to do a little bit of algebra. You have to set the function equal to that and then solve when does that equal to it. So let's do one real quick here before I let you guys go. Let's do a quick example of how that works. Right? So let's take a look here. Let's say I was asked to find the average value of f of x equaling to 2x plus 3 on the interval 1 to 5. Right? And after that, I need you to find a c in the interval 1 to 5 such that f of c equals the average value. Okay? So check the first things first. Is this function a continuous function? And 2x plus 3 is a linear function. It's a line that is continuous everywhere that's on this interval from 1 to 5. Right? So let's go ahead and do this real quick. So what I'm saying here is that to find the average value, all we got to do is look for 1 over b minus a, but in this case, a is 1, b is 5, so it's 1 over 5 minus 1 times the integral from 1 to 5 of 2x plus 3 dx. That's all you have to do to find the average value. Okay, and you could also practice this using your TI calculator, plugging in the integral to calculate this. But at this point, for these integrals, we can do these by hand, right? So let's do this real quick here. I have that written down, so I don't need that anymore. So we're going to go ahead. 1 over 5 minus 1 is going to give me 1 over 4. The integral is asking me to do the antiderivative of what's inside there. Remember, the antiderivative of 2x is x squared, because again, if I take the derivative of x squared, I end up back at 2x. Plus the antiderivative of 3, that's just going to be 3x, because again, if I take the derivative of 3x, I just end up back at 3. This is, of course, being evaluated from 1 to 5. Right? So I would plug these values in for x. So this is going to be 1 over 4. This whole thing is going to be multiplying here, and I'm going to do it in here in the first set of parentheses here. This is going to be 5 squared plus 3 times 5, right? Minus 1 squared plus 3 times 1. Right? All I'm doing here is evaluating these guys right here. So this 5 is being plugged into x here and here, right? Like so. And then I'm plugging in my 1 in for x over here and here, and I'm subtracting the 2, right? If you guys remember, that is the fundamental theorem of calculus, right? That allows us to do that. It's f antiderivative evaluated b minus the antiderivative evaluated a. So plugging that all in, doing this into your calculator, right? This would be 25 plus 15 minus some number divided by 4. If you plug this in your calculator, it comes out to exactly 9. Okay? So the average value of this function right here is equal to 9. So that part is done. I found the average value. Check. The next thing you need to do is find the value of c such that f of c is equal to that average value. So I'm asking you, when does 2x plus 3 equal to 9, right? So we solve this guy right here. We end up here with 2x is equal to 6, x is equal to 3. So f of c here is going to equal to 3, right? So that means f of 3 should be equal to 9, which is the average value. But this is the part right here. And 3 is in the closed interval from 1 to 5. And that's the mean value theorem of integrals in a nutshell. I know it was kind of like a lot there. So what I want to do today is assign a video for you guys to watch on College Board. So let me go ahead and pop that up real quick. So if you go onto College Board, let's go over to BC real quick here. I'm going to assign these videos, but new assignment features. You can now assign assignments to individual students. Oh, neat. We'll do that later. Let's go ahead and take a look here. We are in chapter 6 for the college stuff, but chapter 5 for me. Let's see here. The fundamental theorem of calculus, interpreting behavior, applying properties, fundamental theorem of calculus, using substitutions. No. We don't want to go that far. Where is the... Oh, I guess they don't have that on here. Interpreting behavior, fundamental theorem of calculus, finding antiderivatives and integrals, using U substitution. Huh. It's not under here. It's probably under another different unit, but we'll leave that for another time. Actually, what if I type in here? The mean value. Oh, geez, dog. Dog just scared me there for a second. Okay, that's just going to take too long. All right, anyways, guys, I'm going to wrap it up there. We do get out in like 3 minutes or so, but I'll find this one up and I'll post it on there for you guys to work on the College Board site. But aside from that, I don't actually have any homework yet for this one. We're also going to do more examples. That way, you feel a little more comfortable with it. But yeah, I think that's going to be it for today, guys. Now that we've gotten through over it, I'll show you how to do these problems. They're actually fairly simple, fairly easy, and then that's going to be it. All right, guys. Have a good rest of your day. I'll see y'all tomorrow. Have a great day, guys. and gals and everybody. So long, everybody. Bye.